So this lesson is going to show you how to calculate the area that is underneath the curve given a certain z-value. Now what the z-value is a standardized score. So what we were dealing with our ruler experiment was numbers between 0 and 12. Okay, if you're measuring something else, I'll stick to the height example. You would be between 0 and maybe 80 inches or 0 and 100 inches or something like that. If you were dealing with weight, you would be somewhere between 0 and into the hundreds of pounds. So you could be all over the place, and they don't have a table or a chart that can cover all those different things, right? Because all those different sets of values have a different mean and a different standard deviation. So because those are all so different, there's really no chart that they can have that will tell you, okay, this is how many data points fall above or below that value. And so what they do is, this is where we use the z-value or the z-score. We figured this out in previous chapters, but it's a way of standardizing it. It's a way of putting it into apples to apples. Instead of comparing apples to oranges, you convert it to a z-value, and now it's a standardized score. So again, this was the formula for a z-value. So you take whatever value you're looking for, you subtract the mean, and you divide it by the standard deviation. So this is how you take the value and turn it into a standardized z-score. Okay, here's my example. If we were looking for like what percentage of people caught the ruler up to 8 inches, right? So we're looking up to 8 inches. So we're looking at 8 inches or less. What percentage of the people, of you students, caught that ruler at 8 inches or less? Well, what we're looking at doing here is taking that number 8 and converting it to a standard score. So the value we would use would be 8 right here. We would subtract whatever our mean was, which was somewhere between 5 and 6, and we divide it by our standard deviation, which we never figured out. Okay? Here's the symbolic version of it. So once you have that z-score, we're going to be looking at, okay, so think of it this way. Here's your mean. So now we're looking at a normal distribution graph, where, remember, on a normal distribution graph, they have the mean of 0 and a standard deviation of 1. Any positive z-score is to the right of the mean over here, and any negative z-score is to the left over here. Now we're going to be looking at a table in the back of the book in a second, and that table tells you what percentage of the scores are less than the z-score. So keep in mind that if you're looking at a positive z-score, you're looking at the area less than it, all of this over here. If you're looking at a negative z-score, you're looking at the area of values less than it, so all the stuff over here to the left of it. Okay? So that's really easy. If you're looking for less than a z-score, the number you get in the back of the book, that's your answer. That's an easy one. If you're looking for the value above, so I said what percentage of people grab the ruler higher than 8. Okay, we would turn that 8 into a z-score. We would look for the value in the back of the book, and then we'd have to realize that, let's say here's what 8 turned into as a z-score. The back of the book would give us this over here. Well, to find the area over here to the right of it, which is greater than it, we would have to subtract the area for 1. So this is that table in your book, and it's simply an explanation of how to calculate it. I think for most of you, it's going to just be, you're going to understand it. It's going to be pretty intuitive. But if you have to look back at this from time to time, that's perfectly fine. What if you're looking between two z-values? Well, keep in mind that you're going to get a value for this one, which is less than, which would be all of this, and you're going to get a value for this one, which would be all of this. Well, if this is, let's say, 0.8, which is all of this, and this is 0.3, which is all of this, you would take the 0.8, which is all of it, subtract the 0.3, and that would give you everything in between. So basically, you're just subtracting, you're taking your big number minus your small number to find between. Okay? So here's some examples. So what we want you to do is turn to page 782 while you're going through this, and that way you can follow along. So whatever set of data we're looking at or we're using, we've taken some value and we've turned it into the z-score of 1.99. So we've used our z-score formula and we've turned it into the value of 1.99. So they are asking, what's the area to the left of 1.99? So you're on page 782. You're actually going to, on 782 is all of your negative z-scores. You're going to have to go to 783. And on the left, you'll be looking for your whole number and your first decimal, your tenths of a decimal. So that would be 1.9. So you're looking for 1.9, and then you move to the right and you look for the 0.09 column, because 1.9 plus 0.09 would give you 1.99. That's what we're looking for, and that value is 0.9767. Okay, so row 1.9 and column 0.09. So all of this area, okay, covers about 97.6%, 0.7% of all the values. So again, think of this. If this was our experiment, and these were all the data values of people of all where you grabbed the ruler, and we were looking for the number of whatever, let's say it's 8, and we knew the mean, we knew the standard deviation, and we did our z-score formula, and we turned the number 8 into 1.99. What that would mean is that about 97.7 or 97.67% of all of you students caught the ruler less than 8. Okay. I'm not sure what value would represent this z-score, but that's an example of this. Okay. What if we were looking to the right of z equals negative 1.16? So we go to our chart, we look for negative 1.1, we go to the right and we look for the 0.06, and that turns out to be, oh, I lost it, 0.1230, but we're looking for the area to the right of it, so we're looking for all of this. So we go 1 minus, because remember, the table is telling us the value, or the area right here to the left. So we take 1 minus that, and that'll give us everything to the right. Okay. What if we're going between? We have to find 2 of them. So again, using your table, for 1.68, that's the 1.6 row, and you go over to the 0.08. That's 0.9535. The area for negative 1.37 is 0.0853. We subtract those 2 values, and we get an answer of 0.8682. Fall between. And what if you get something like this, between 0 and 2.32? So 0, if you look up 0, So the zero row and the 0 column, it's 0.5. And that's because the mean is the middle. 50% is below, 50% is above. So we're looking for the 2.32, and that's 0.9898. And we know that this is 50%. So the 0.9898 is everything, all of this in here. And the 0 is 50%, so we want to subtract that 50%, and that tells us that this area right in here is 0.4898. And the last one, what if they want the z-value such that the area under the standard normal distribution curve between 0 and the z-value is 0.2123. So what we're asking for is, what value right here would it have to be where this area is 0.2123? Think about it. We are looking for a value on our chart that represents basically all of this right here. All of this area in here. We're looking for all this area right in here. And the reason we're looking for all of that is because this is our cutoff. And so we want to know what z-value would be all of this. Well, what value would that be? We need all of this that we're looking for, the brown area, which is 0.2123, plus we're missing half of it. So what's 0.2123 plus a half? You get 0.7123. So here's what we're looking for, the value that is the closest to 0.7123. So you go to your book, and you're looking for 0.7123. And we actually find it, exactly 0.7123. And so what number represents that? Well, it's 0.5 and 0.06. So if you put those together, that's 0.56. So your z-value is 0.56. If you couldn't find that number exactly, you would do whatever one is closest. Okay? So if your z-value ended up right here between two of them, you do whichever one is closer. Okay, that's your video. Look through these examples again. I think it's pretty straightforward. If you